Okay, it's live. Hi guys, welcome to Smarter R. So today we will learn how to calculate ETCCDI indices by using R. So we will calculate consecutive dry days (CDD). So if you are not familiar with ETCCDI indices, it is indices to calculate extreme rainfall and not just extreme rainfall, it just to calculate extreme climate. So in this case, we will calculate consecutive dry days. So there is a lot of software out there or some programming or something like that that will help you to calculate these indices, but it will only help you to calculate only one point, one grid point. But we have a lot of station data, we have a lot of gridded data, a lot of grid point that we want to calculate in one go. So it will be very fast. So this is the purpose of this tutorial. We will use R, the power of R, the power of the library, the packages in R. So let's start. So step one, you just load your library, the player package, and lubricate package. So install this package and load it. Okay, now we set our working directory where we put our dataset. So I put my dataset here. So let's see my dataset in WISE here. So you just copy the address, folder address, you put it here, but make sure you change the slash there to like this, 2/. So you set working directory, set WD, set your working directory where you put your dataset in this folder, and then run it. And then step 3, you read your dataset. So I have my dataset, daily rainfall data, chips JRB grid 005. Let's see our dataset first. So here. It is in the CSV file. Make sure you save your dataset in CSV file. So you have you must arrange your data like this. You have your year, month, day, and your grid point V1 until 109. So I have 109 grid point. This is chips rainfall dataset. The dataset is in daily rainfall. So if you have station data, you can use your station data, put it here, replace everything. The how many column is it? It's up to you. It's not a problem. So my data set is daily data, daily rainfall data from 1981 to 2021. So to calculate ETCCDI index, you must have at least temporal resolution of daily data. So arrange your data like this. Now we read our data set as a variable date. Use read.csv function. Header is equal to true. So we want to read the header also up here, the header. So we run this. That you also can view your data here by using the view function. You can see this is your data. It will view in CSV in the our environment. And you can just drag this one to see all the data. So it's there. It's all is there. After that, step 4, you want to convert year, month, and day column into a date format. So we first want to convert it into a date format because I don't know, CSV cannot prepare this kind of data set. That's the problem. So we convert this by combining that year, that month, and that day into a date format by using a function paste and as date. So that we have our date data just now, right? This one data, right? And then we will create using a dollar function here, create another column, additional column for date. So we run this one. I will show you now. So I will show you, just run this line of code. You see, it will create another column with a new format of date, this format. It will be created here. So we view our new data set. You see, it's the same data set just now, but at the end, we create another column. So it will have a date format like this. So the date format must be look like this. it with dash 1981 dash month dash day for daily rainfall. We create another column. Now, we define a function to calculate, step 5, we define a function to calculate CDD for a given vector of precipitation value. So this is the code. The function here is to calculate, how we want to calculate consecutive dry days. So we use the function will be calculate CDD. So precipitation vector is the daily rainfall. So we want to calculate the consecutive dry days and the maximum consecutive dry days for uh, for each month. I think this is for each month, consecutive dry day for each month or each year. We will see later. I can't remember. So precipitation value must be less than 1. We want any days that is have rainfall less than 1. So that day is considered as dry day. So this is definition given by ETCCDI indices. So any days that even though it's rainfall, but the rainfall is less than 1, so that is dry days. If the rainfall higher than 1 or equal to 1, that is wet days. So for this case, we will calculate dry days. And then we will calculate the consecutive dry days, the maximum amount. We will only calculate the maximum for each month. So we want to know at each month, when is it, how the event that is the most extreme dry days, how long is it, something like that. So we'll calculate this function. Okay, we already calculate this function. So this function is actually the calculation, the maths, the mathematics is calculate. So we will use this calculation, the function, to create a data frame, and then we will do a loops. So this is the explanation just now. We define the function to calculate consecutive dry days, and then we iterate to each precipitation value. If the precipitation is less than 1 millimeter, increment the consecutive dry days counter. It will start to calculate. That is the start of the dry days. It will calculate. And then it will update the maximum consecutive dry day if the current count exceed the previous maximum. So each month it will calculate only the maximum dry days for each month. And okay, now we go to step 6. We create a data frame to store the annual CDD result. So we create a data frame. So this is annual CDD, or it will actually calculate annual CDD. So in 1 year, it will calculate when is it the longest dry day. And then we create annual CDD here is actually to create a new empty data frame where we will put our result later on. So it is empty. You see, the result is empty. So after this, we will put the result by using our function to loop it for all the column to calculate each grid point, to calculate each station, loop it, and then we will calculate annual CDD and put it into this empty data frame. So we loop each column from column 4 until 112. So our data set just now, we have start the station from column 4 until the end. So if your data grid point or station have only maybe 15, you put 15 here until 15. But my data set is until 112. So I will use 112. So I will nested the loop to calculate CDD for each year and each column. And then you can just use this data set to calculate all the column, all the grid point or station data that you use. So run this. So it's very fast. And then we save, we can view our result actually already here. You see, we name it as annual CDD. We can view it. This is dry days, maximum dry days. So the unit for this result is days. So we have 10 days, 15 days, 22 days, but we don't know which month. So because my calculation is for annual, but you can, if you want to calculate monthly, then prepare your data monthly. But I will, if you need that kind of code, I will tell you. But this is for the calculation that is a standard calculation for ETCCDI index. So some days it's very high. You see 32 more than 1 month. 1996. Oh, I think this is during El Nino in Malaysia. So up more than 32 days, no rainfall. Oh, this is quite significant day, significant year that don't have rainfall. So after that we save our result into CSV file, white as CSV. So I know CDD just now, our new data set of CDD that we have calculated. So I will calculate. I will put it into CDD manual. Row names is false. So let's see our result. Okay, it's already calculated. CDD. Okay, yeah. No, this is the trend result. CDD. Okay, yeah. Oh no, it's we want the manual one just now, but it's okay. This here down here. This is our result. Okay. Okay, this is our result. We can just print it back into CSV file. So the 10 days is the maximum dry days in 1981. 15 days is the maximum consecutive dry days in 1982. So we can just view the result also like this. You can see this is the result. Some years is very high dry days just now, more than 30, more than one month. 2 years have more than 1 month. So I think this is definitely El Nino event. So this is how you calculate CDD by using R. So you calculate everything, all the grid point all together in one go. Easy compared to all other programming out there. It's still R also. They use, last time I tried to use some code, something like that. They only calculate one by one. Even though it's calculate all the indices, but it's calculate only one grid point at a time. But now we have gridded data, we have a lot of station data. This way is faster. If you can refer to all my other tutorial to calculate manually by using R, all the other indices. It will be very fast compared to calculate one station at a time. It's very difficult. And then you need to arrange the data again. It's very difficult. Okay, thank you for watching. So I hope this session will be very helpful for you. If you have any question, comment, like, and subscribe my YouTube. Thank you for watching.